Hi, I just wanted to talk a little bit about arithmetic sequences. So these are ultimately nothing crazy. You probably will intuitively know what to do with them. You just have to be careful with them on some of their notation and making sure that you're using the correct form when it's asking for the right thing. So ultimately, what we're going to start with is that we are going to start with finding the common difference between terms of an arithmetic sequence. So again, as a reminder, a sequence is just any list of things. In this particular case, it's a list of numbers, um, and they're in order, right? So the big component of a sequence is there has to be an order to it. The order does matter in these. And an arithmetic sequence is it's just one that each term of the sequence, so each element of that, differs by the same thing. So consecutive terms, I mean. So from 2 to 4 and 4 to 6 should have the same difference. Now, obviously, just looking at this one by inspection, what you could do is clearly tell that the difference between the two of them is just going to be 2. But how would you actually do that? Well, if this is the first term, we'll call this A1, and this is the second term, we'll call this A2, you would do A2 minus A1. All right, so that would be 4 minus 2, which is just 2. Similarly, you could do that here. You would do your difference is equal to A2 minus A1. And again, this is just saying the second term minus the first term. Doesn't matter which two terms you pick. You can pick the 17th and the 16th, the 143rd and the 142nd. Doesn't matter. But just pick two consecutive terms and subtract them. All right, so that would be negative 13 minus a minus 9, which is plus 9, which is equal to negative 4. All right, so be careful on this one. Our difference is negative 4. The other thing I did want to say is you'll notice I am using this notation, A2, A sub 1. So these are just saying what term number it is. Another notation you could use is you could use A in parentheses of n. So you could use a function notation where A of 1 would be equal to, in this case, 9. A of 2 would be equal to negative 13, right? So you could write this using a function notation, which is why this is in the section that we're talking about functions. All right, so ultimately, what are we saying? We're saying each term is equal to the one prior to it plus the difference, right? So 2, the second term, is equal to the first term plus the difference. The third term is equal to the second term plus the difference. So we can set up this type of formula called a recursive formula, where basically a recursive formula is just a formula where the nth term can be found by using the n minus 1th term. All right. So as you can see here, I'm saying my nth term, my n, where n is whatever number term I'm on, is equal to the prior term minus 4. So in this case, we're saying our difference is 4. So the actual formula in general for a recursive function, right, is that. So all we're doing is we're saying we're taking my 5th term and to find my 5th term, not 4. I'm sorry, I wrote the difference there, plus my difference. Okay, so all I'm saying is I'm taking my 5th term, and to find my 5th term, I use my 4th term, and I just add my difference to it. If I wanted to find the 172nd term, I would just find the 171st term and add the difference. Obviously, you can tell this only works if you know the prior term, but ultimately, for low numbers, this is perfectly reasonable. Additionally, if you so desired, right, you could use your function notation, and you could do something like this. All right, so these are equivalent. This is just me using the function notation, but this is way more common. So if I want to find the 5th term, A5, well, what am I going to do? So to find A5, I just need A4 minus 4. And okay, well, that's simple enough, but I don't have A4, so I'm going to find A4. So, well, I need A3 minus 4. Well, that's great, but I don't have A3. So I'm going to find A3. Okay, well, A3 is equal to A2 minus 4. Well, that, once again, is all well and good, but I don't have A2. So now I have to find A2. Well, A2, that's just equal to A1 minus 4. All right, and well, luckily I do have A1. It's 5. So I'm just going to plug that in. So A2, that's equal to 5 minus 4. So A2 is going to be 5 minus 4, which is 1. Okay, so now I'm going to plug that in. So A3, I'm going to erase that. Let's make it a different color so you can see. Hello? Oh, okay, doesn't want to change colors on me. So that would be 1 minus 4, which is negative 3. Okay, so now I'm going to, oh, there it goes. Now I'm going to erase that. So now I know what A3 is. So it's negative 3. Well, negative 3 minus 4 is negative 7. Again, I'm going to erase that. Negative 7. So negative 7 minus 4 is negative 11. All right, so I have A5 is negative 11. So then there's my answer. That's all it took. Now you can tell immediately these are kind of annoying when you have larger numbers that you have to deal with. So similarly, if we were to find A4, again, I would need to go through those steps. So let's just start at the bottom. A2 is equal to 6 plus 1, which is 7. So A3 is equal to 7 plus 1, which is 8. A4 is equal to 8 plus 1, which is 9. Now, I'm sure you can already kind of see there is a pattern happening here, right? I added 1 3 times to find the 4th term. And essentially all it ends up being is 6 plus the 3 times 1, right? 9. So just kind of keep that in the back of your head while you're thinking a little bit more about this. So ultimately, if I were to find, in general, the recursive formula for any given sequence, I need 2 things. I need the term before, and I need the difference. So negative 1, let's find the difference to start off here. The difference is equal, minus 3, which is equal to negative 4. All right, so that means my difference is negative 4. And if I want to find the nth term, well, that's simple enough. All I need to do is I just need to know the nth minus 1 term. And that's just, in general, what your recursive formula will be. Now, again, this is nice for certain situations where you already know certain terms. It's really helpful. It's also really helpful if you're dealing with low numbers. But obviously, this is not really nice if, say, for instance, you had to find, let's say, the 84th term. So what are we going to do? Well, we can use something called the explicit formula. As we talked about over here, we can kind of think of this as being, well, we've added the 1 3 times. So I added the difference 3 times. And ultimately, I just ended up adding it to the initial thing. So I could have just said my A4 was equal to A1 plus 3 times my difference, right? Similarly, up here, what did I end up doing? I ended up adding negative 4 times to get to A5. So just from that kind of thought process, if I go back down, the explicit formula that you can use in general for an arithmetic sequence is that an is ultimately going to be equal to the first term plus n minus 1 times the difference, right? When we were trying to find the 4th term, we ended up multiplying the difference by 3. When we were trying to find the 5th term, I multiplied the difference by 4. So that's where the n minus 1 is coming from. The nice thing to remember is the n minus 1, or I'm sorry, the n's in general have to be 1, 2, 3, 4, 5. They're the counting numbers, right? Because you're dealing with the first term, second term, third term, 4th term, 5th term. because it's the number of terms. So to find the 84th term, I'm just going to have to plug all of this in. So if I wanted to find the 84th, well, I just need my first term, which I already know is -5. Now I just plug in 84. 84 minus 1 times the difference. Well, I need to find the difference. It's 15 minus a -5, which is +5, so it's 20. 20 times, good, that's a nice number. 83 times 20, so -5. If I did 20, that'd be that should be 1660. And then -5 from that. And there you go. So now, obviously, if I was doing with the recursive formula, I'd be here forever. That's not to say, again, that recursive is not without its uses. It is. It has situations where it's very important. But it's not this one. Again, similarly, if I were to find the 53rd term, okay, I would do my first term. Well, I had to find my difference, right? 11 minus 27, -16. All right. Plus, well, that ends up being 52, right? Because it's 53 minus 1 times -16. Well, what is going to be 52 times -16? I don't know this one on the top of my head. Equals 27 minus 832. So that would be -805. Right? So again, that would be really annoying to do with the recursive formula. Now, if you were to just try and write these in general, again, we really only need the first term, and you need to know what the difference is. So what you can do is you're just going to write it as, again, you just need the first term plus n minus 1 times the difference. Well, what's my difference? It's going to be 13 minus 9, which is 4. And what's my first term? 9. Now, depending on what we're specifically looking for, you could either leave it in this term or in this form, or you can simplify it. So if you distribute, you get 9 plus 4n minus 4, which is equal to 5 plus 4n. That's perfectly acceptable. Either form works. Just be careful depending on what Savas is looking for, or you might accidentally get something wrong. All right, similarly on this one, let's find my difference. 6 minus 16, -10. So my an is going to be equal to 16 plus n minus 1 times -10, okay, which is equal to 16 minus 10 n plus 10. So 26 minus 10 n. All right, and again, depending on what form it's looking for, it's sometimes okay to leave it like this, and sometimes you might need to simplify to there. All right, so ultimately, that is everything that you need to know for arithmetic sequences. Please let me know if you have any questions. Have a good day.